Enroll your child for the Manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
How are you, my student? Welcome to our maths lesson today. My name is Purity Anzelimo. Our topic is trigonometry. Trigonometry. And in this case is trigonometry 3. Trigonometry 3. We've already covered trigonometry 1, 2, and now we are in trigonometry 3. Trigonometry 3. So it is not a new term, it is a continuation of trigonometry 1 and trigonometry 2. Now in this topic, trigonometry 3, I would like to give you what we are going to cover in this topic. So I'd like to give you the topic outline. The topic outline, what we are going to cover under this topic. One, we look at the trigonometric identity. Trigonometric identity, whereby we are going to derive that identity and then we are going to use it in simplifying various trigonometric expressions. Then after that, we'll also look at waves. In our previous topics, that is trigonometry 2, we looked at waves, how to plot waves. In this case now, we are going to look at the waves. We'll be able to plot them once again, and then we are going to calculate or to get the amplitude. We'll be using the waves to get the amplitude and also the period. So what we are adding in this case is the amplitude and the period. Then after that, we'll also look at the transformations of waves. We look at the transformations of waves. We look at the transformations of waves. And then finally, in this topic, we are also going to look at equations, trigonometric equations. Trigonometric equations, whereby we are going to solve these equations. So this is what we are going to cover in this topic, the trigonometric identity. We derive and then apply then the waves. We are going to plot them. We get the amplitude and the period. Then we are also going to look at the transformations of waves, whereby we are going to plot the waves then being transformed. Then we are also going to describe the transformations. Then we'll also look at the trigonometric equations, whereby we are also going to solve these equations. Before we start with this, the outline, before we start with the some topics that we are going to cover in this topic, that is trigonometry 3, I would like to do a recap of what you have covered in trigonometry 1 and also trigonometry 2. So I would like to start with the trigonometric ratios. Trigonometric ratios. Just to remind you what you covered in the previous topic on trigonometry. So trigonometric ratios, in this case, we have the sine, which we write as sin. We also have the cosine, which we write as cos, and we also have the tangent, which we write as tan for the tangent. Now, I would like us to consider the following. Consider the following right angle triangle. Consider this right angle triangle here. This is what we have. Let's say that we have A here, we have B this side, and we have C. This is our base A, then we have the height B and the hypotenuse C. And let's say that we have our angle here. This is angle theta. So if we want to get the sine of theta, is given by this sign, which is the opposite. We can call this is our opposite sign. That is from where the angle is. We have the opposite. We also have this sign when the theta is here. This is the adjacent. And here we have the hypotenuse. Hypotenuse. So when we want to get the sine theta is given by opposite divided by the hypotenuse. So we have opposite. Let me write it down here. The sine theta, we start with sine, cos, and tangent. Sine theta, we have it as the opposite. We have opposite divided by the hypotenuse. Hypotenuse, which is the same as our opposite is B, and then the hypotenuse is C. That is for the sine. Then we move on to the cosine, the cos theta. Cos theta is given by the adjacent all over the hypotenuse. Adjacent, from the previous knowledge, adjacent all over the hypotenuse. Hypotenuse, which is equal to, our adjacent is A, hypotenuse C. So we have A all over C. Then finally in this we have the tan theta, the tangent. Tangent is given by the opposite all over the adjacent. Opposite all over the adjacent. Our opposite side we have B, and our adjacent we have A. Now we have the cosine, we have the tangent, and we also have the sine. We can even make a conclusion from this because you don't need to clamp so much on this. You can simply come and say we have what we call the SOHCAHTOA, whereby sine is equal to opposite over hypotenuse. Then the cosine is equal to adjacent all over the hypotenuse. Tangent is equal to the opposite all over the adjacent. So you make note of this, the SOHCAHTOA, such that when you are trying to find the cosine, it is simply the adjacent all over the hypotenuse. The tangent is the opposite all over the adjacent. Now, I also want you to observe this, again from your previous knowledge. If I take now the sine theta, if I take sine theta and I want to divide by the cos theta, look at this keenly, the sine theta all over the cos theta. This will be the same as saying our sine theta is B over C. So we'll have B over C, which is our sine theta. Then we are dividing by cos theta. And our cos theta is A over C. So we are dividing by A over C. So if we divide this, we are going to get this as B over C. We multiply by the reciprocal, which is C over A, by C1 by C1. So we end up getting B all over A. So we can say that sine theta divided by cos theta is equal to B over A. And if you are keen enough, you can see that tan theta is the one that is equal to B over A. So, but we know very well that tan theta, the tan theta is equal to B all over A. And therefore, we can conclude that sin theta all over cos theta is equal to tan theta. Sin theta, the sin theta over the cos theta, we can conclude therefore that sin theta divided by cos theta is equal to tan theta. So you also need to note that when you have sin theta, you divide by cos theta. Sin theta is this. Divide by cos theta, you are getting the tan theta. Therefore, sin theta over cos theta is equal to tan theta. Then something else that you also need to remember is how to get the cosine, the tangent, and the sine of 30 degrees and 60 degrees without using the tables, without using the mathematical tables. Cosine, tangent, and sine of 30 degrees and 60 degrees without using the tables. Now, in this case, I would like you to consider an equilateral triangle. Consider an equilateral triangle. Consider this an equilateral triangle. For an equilateral triangle, the angles are 60 degrees and all the sides are equal. All the sides are equal. So assume that this is our equilateral triangle. This is the equilateral triangle whereby all these sides are equal. Now, in this case, I want us to use this triangle to be able to calculate the sine of 30 degrees, the cosine of 30, the tangent of 30, and the same case applying to 60 degrees without using the tables, Now, in this case, we consider this triangle to be of 2 units. Every part we have two units. And I want us to drop a perpendicular bisector of this angle. A perpendicular bisector here, whereby we have it this way. So in this case, this is our perpendicular bisector. This will be 90 degrees. And then from here up to here, because this bisector will divide, if we have, let's say, this A, B, C, it will divide AB into two equal parts. So this will be 1, that one will also be 1. So if you want to get the height of this triangle from this point to this point here, we have to use the Pythagoras theorem, whereby we have the hypotenuse squared. This is the hypotenuse squared is equal to the base squared, that is 1 squared, plus the height squared. So for us to get the height squared, we take the 2 squared minus the 1 squared, which will be equal to 4 minus 1, that is 3. And therefore, h will be the square root of 3. So in this case, we have the height here as root 3. Remember, this angle is 60 degrees. This is 60 degrees. This one is the perpendicular bisector. So this angle has been divided into 30 degrees and 30 degrees. So we can use that triangle. It's a special triangle. We can use it to calculate the cosine, the tangent, and the sine of 30 degrees and of 60 degrees. Because you can be given such and you are told to find without using the tables. So you remember our formula for the trigonometric ratios, that is SOHCAHTOA. So in this case, we can have a small table whereby in this side we have the sine. We'll be getting the sine. On this one we have the cosine. Then here we have the tangent. So we'll have the sine. We'll be having the sine of 30 degrees, cosine. So in this case, we can have the sine of 30 degrees. We can start with the sine of 30 degrees. Sine of 30 degrees. Let me just write it as sine 30. Or we can have the angles. Then we have the sine, the cos, and the tangent. We have the angles, that is 30 degrees. And we also have the 60 degrees, 30 and 60 degrees, 30 degrees, and we also have the 60 degrees, 30 and 60 degrees. So in this case, we want to get the sine of 30 and 60, then we get the cosine of both 30 and 60 degrees, then we also get the tangent of both 30 and 60 degrees. So let's start with the sine of 30. We can see from here sine is given by opposite all over the hypotenuse. So sine 30, our 30 here, is equal to the opposite, which is 1, divided by the hypotenuse, which is 2. And therefore, we have 1 over 2. Then we move on to sine 60. We have 60 here. With this one, you can use anything. It will give you the same thing. So sine 60 again, we have opposite, which is root 3, all over the hypotenuse, which is 2. So we have root 3 over 2. Root 3 all over 2. Then we move on now to cosine. Cosine we have adjacent all over hypotenuse. So cos 30 will have adjacent, which is root 3, all over the hypotenuse, which is 2. So we'll have root 3 all over 2. Then for 60 degrees, we have cosine as adjacent, which is 1, all over the hypotenuse, which is 2. So we'll have 1 over 2. Then finally with the tangent, we have tangent is equal to opposite all over adjacent. So 30 degrees we have opposite all over the adjacent. So we have 1 over root 3. 1 all over root 3. Then for 60 degrees, we have 60 degrees tangent opposite, which is root 3, all over the adjacent, which is root 3 over 1, which is the same as root 3 over 1, which is the same as root 3. Now that's what we have using our special triangle, this equilateral triangle. We are using it to get the sine, the cosine, and the tangent of 30 degrees and 60 degrees. Again, you can see clearly from this, again what you covered in the previous lessons, you can see that sine 30 degrees is the same as the cos of 60 degrees. And sine 60 degrees is equal to the cos of 30 degrees. These are complementary angles. The cosine and the sine of two complementary angles is the same. The cosine and the sine of complementary angles, complementary of two complementary angles, the cosine and the sine of two complementary angles is equal. Remember, complementary angles are angles whose sum is 90 degrees. So if you look at 30 and 60, the sine of 30 is a half, and the cosine of the complementary angle, which is 60, is a half. The sine of 60 degrees is root 3 over 2. The complementary angle for 60 is 30, and therefore the cosine of that complementary angle, which is 30, is the same root 3 over 2. So that is how we can use this equilateral triangle to find the cosine, the tangent, and the sine of 30 degrees and also 60 degrees. Now, I also want us to look at how we can find the cosine, the tangent, and the sine of 45 degrees. Now, for 45 degrees, again, without using the tables. Without using tables. So we can look at also how to get the cosine, the tangent, and the sine of 45 degrees now. 45 degrees, in this case again without using tables. Without using the tables. Without using the mathematical tables or even the calculator. In an exam, you can be told to find, for example, the cosine of 30 degrees without using the calculator. So you are, and also the table. So you are supposed to have that equilateral triangle, that is the special triangle. For the equilateral triangle, the signs we have 2, 2, 2. That is for the equilateral triangle. Now, in this case, we'll consider a right-angled triangle. Right-angled triangle. We consider a right-angled triangle. So in this case, we'll have the following, so that we can be able now to get the cosine, the tangent, and the sine of 45 degrees without using the tables. So we have a right-angled triangle here, the right-angled triangle. So we have it this way. This is our 90 degrees. So we can see that this side is our base. This we can call it, if we have the angle here, because this is 90, this is 45 degrees, and this one is 45 degrees again. And therefore, these two angles are complementary. Their sum is 90 degrees. So here, if we are taking this one, we'll have this side as our adjacent. We'll also have this side now as our opposite. This is the opposite. And we'll have this side as our hypotenuse. Now, we can see now from this, therefore, we start with the cosine, cos 45 degrees. From SOHCAHTOA, we have SOHCAHTOA. So we'll have cos 45 is equal to adjacent all over the hypotenuse. In this triangle, we consider it every side to be 1. The two sides, that is the base is 1 and the height is 1. The hypotenuse, from the Pythagoras theorem, we are going to have 1 squared plus 1 squared, then the square root. So we have 1 plus 1, that is 2. So we'll have the square root of 2. So the hypotenuse is root 2. So in this case, cos 45, we have adjacent, which is 1, all over the hypotenuse, which is root 2. Then if you want to get the tan of 45 degrees, the tangent, again we have the opposite, which is 1, all over the adjacent, which is 1. So which is 1. 1 over 1 is 1. Then finally, we have the sine 45 degrees. In this, we have sine is opposite all over the hypotenuse. So we have 1 all over the hypotenuse, which is root 2. Again, you can clearly see, it's very clear, that cos 45 and sine 45 is equal, because these are two complementary angles, and we have said that the cosine and the sine of two complementary angles is equal. Then I also want you to note clearly, we can come up with this identity also, that sine theta all over cos theta is equal to tan theta. We can prove it even from this and see whether we are going to get one. So in our case here, cos 45, sine theta or sine 45 is 1 over root 2. We divide by cos theta, which is 1 over root 2. So we'll have 1 over root 2 multiplied by the reciprocal, which is root 2 over 1. By root 2, 1, 1. 1 over 1 is equal to 1. And our tan 5 is equal to 1. And therefore, this has been proved that sine theta over cos theta is equal to tan theta. So we can use these special triangles, that is for the equilateral triangle and also the right angle triangle, to find the cosine, the tangent, the sine of 30 degrees, 60 degrees, and 45 degrees without having to use the tables. That is knowledge that you have already learned. Then also, I'd like also to mention something about the unit circle. The unit circle, something small on the unit circle. The unit circle. In the previous lessons, or in the previous topic, that is in Trigonometry 2, a unit circle is a circle with a unit radius and center 0, 0. So for a unit circle, the radius, has a unit radius, and then the center is 0, 0. This is what we mean. If we have our circle here and we have our center, let's say we have our center at this point here, when we are using now the Cartesian plane, in the Cartesian plane, the center should be 0, 0. So this is what we have. This is our y-axis, and this is our x-axis. This is the x-axis. So when we are talking of the unit radius, it means that this is 1, this is -1, again this is 1, this is -1. That's what we refer to as a unit circle. Unit radius, and then the center is 0, 0. That's a unit circle. Now in this circle, we start from this point here. This is what we call the first quadrant. This is our first quadrant, because a circle is made up of 4 equal quadrants. So this is our second quadrant. We have our third quadrant, and then we have our fourth quadrant. This is what we have. So we start from this point here where we have the 0 degrees. Then at this point here we have 90 degrees. At this point here we have 118 degrees plus 90. We have 270 degrees. And then back again here we have 360 degrees. Something I'd like to remind you is, where is the sign positive, where is the tangent positive, where is it negative. So I'd like to remind you how we get to know whether the sign is negative here or positive, or the tangent here is positive or negative. Now in our case here, we are saying that this is our x-axis, that is in the Cartesian plane, and this is our y-axis. Now when we are reading the cosine, we consider the x-axis from your previous knowledge. Then with the sine, we are going now to consider the sine of now the y-axis, our y-axis. Like I want to start with the first quadrant here, the first quadrant. The values of x here are positive, and the values of y here again are positive. So we can say here in the first quadrant, the sine is positive, that is on the y-axis, and the cosine is also positive on the x-axis. And therefore the tangent, since tangent is sine over cos, positive over positive will also be positive. Then when we come to the second quadrant, we'll start again with the sine. The sine, we are looking at the y-axis. Our y-axis here is positive, so the sine is positive. Our cosine in this case is on this side of the Cartesian plane, on the left side of the center 0. So this is negative. So we have our cos, which is negative. Then our tangent, which is sine over cos, will be positive over negative, which is negative. That is in the second quadrant. In the third quadrant, we have now the sine here. On the y-axis, we have it as negative. Cosine, on the x-axis, we have it negative. And therefore, the tangent, which is sine over cos, will be negative over negative, which is positive. Then finally, in our fourth quadrant, we have the sine that is on the y-axis as negative. The cos on the x-axis is positive, and therefore the tangent in this case will be negative over positive, which is negative. So in this case, we can say that here all of them are positive. Here only sine is positive. Here we have only tan, which is positive, and here only cos is positive. So here all are positive, all are positive. Here we only have sine, which is positive. Here we only have tan, which is positive, and here we only have cos, which is positive. So from the first all the way to the fourth quadrant, we have A, S, T, C. So you can master this, that here all are positive, sine is positive, tangent here is positive, and here cosine is positive. That is from the first to the fourth quadrant in the unit circle. That's the unit circle. So I'd like to ask to do one question, then I give you an exercise. This is a recap. I'd like us to find the exact value of root 3 over 2 sine 60 degrees plus a half cos 60 degrees, and here without using tables, and calculator. I want us to do that question, then I'll give you an exercise. Find the exact value of what you've been given there, root 3 over 2 sine 60 degrees plus a half cos 60 degrees without using tables and calculator, without using either the tables or the calculator. Now in this case, we can see here we have sine 60, we have cos 60, and therefore we apply the special triangle, that is the equilateral triangle. You remember the equilateral triangle. In this case, this is what we have. Perpendicular bisector, here we have one here, we have 2, 2. This is 90 degrees, and therefore this will be 2 squared minus 1 squared, then the square root, we get here root 3. And this is 60 degrees. This is again 60 degrees. So we want to get sine 60 from this. Sine 60 degrees will be equal to, remember the soccer tour. So sine will be opposite of a hypotenuse. Sine will be opposite, which is root 3, all over the hypotenuse, which is 2. Then we can also get cos 60 degrees. Cos we have adjacent, which is 1, all over hypotenuse, which is 2. And therefore now we can find the exact value of that. We can get the exact value for the question given, the exact value, since we have now cos 60 and we also have the sine 60. So we are going to have therefore root 3 over 2 multiplied by sine 60, which is root 3 over 2 again, root 3 over 2. That's what we have, plus a half cos 60. Cos 60 is a half, so we are multiplying again by a half. So in this case, we end up getting root 3 times root 3 is 3. We know from this root a, from the sums, multiplying by root a is equal to a. So here we are going to have root 3 times root 3, we have 3, all over 2 times 2, that is 4, plus 1 all over 4. And we end up getting 3 plus 1, that is 4, and the LCM is 4. And therefore, we end up getting 4 over 4, which is equal to 1. And therefore, the exact value for that is equal to 1. I would like you to do the following exercise. Exercise number 1, given that given that cos theta is equal to 1 over 3, find Roman 1, find tan theta, and Roman 2, sine theta. Then number 2, find the exact value, of the following. Find the exact value, of, we have in this case 1 over root 3 cos 30 degrees minus 1 over root 2 sine 45 degrees. And in this case again, without using calculator, all tables, without using any of them. Then lastly, number 3, solve the following. Solve the equation. The equation is here. Sin x is equal to 0.8071, and you have been given the range for 0 degrees. Our x is within that limit from 0 to 360 degrees. So find those. In this case, you need to have the knowledge on the unit circle. In the others, you need the trigonometric ratios so that you can be able to answer that. So during the next lesson, now we are going to start with the first part in trigonometry 3. That is whereby we are going to derive the identity, the trigonometric identity. Thank you for being a good student.
Manifested Publishers Limited is a research and teaching center that specializes in the production of learning materials and private online tuition for primary, secondary, tertiary, and university education. Sign up as a new customer at www.manifestedpublishers.com. Fill in the required credentials, full name, email, phone number, and password. Click on Sign Up. Enter the code received on your phone or email address for verification of your account, then proceed by clicking on Confirm button. Your account is ready for use and you can watch some free videos before you purchase. To get access to complete videos, use the following steps to buy. Click on View All Courses. Select the course you want to subscribe to. Click on the subject you want. Click on Buy this subject. The selected subject will be added to cart. Place or hover the cursor on cart or total amount and click on Check Out Now to proceed. Click on Lipa na M-Pesa and proceed to pay. To access your lessons, place the cursor on your name, then click on Subscriptions. To download videos for offline studying, click on Watch Offline. Download the Manifested e-learning desktop application depending on your computer operating system. Install the application on your computer. Sign in on your downloaded app using the credential used during registration. Place your cursor on your name, then click on Subscriptions. Click on the subject you purchased. On the top right window, click on Download for offline viewing. Click on Go to Course. In your new window, click on the first topic, Lesson 1. Downloading process begins automatically. Thank you for choosing to study with us. For more information, you can call us on 0724 173845.